Alright, now that we got the first 5 done, I'm kind of just go through the rest of these pretty quickly, but writing down what the common difference ratio is, initial value, and then kind of just filling in the forms of the equations of functions, and working on getting that 15th term pretty quickly. Alright, so here my common difference is 4, because it's added 4 dots each time. The initial value is 1, so the recursive function looks like this. A sub n equals a sub n minus 1 plus 4. And don't forget the initial value 1, so a sub 1 equals 1. The explicit one would say f of n equals 4 times n minus 1 plus 1, because 1 is your initial value. To get a sub 15, you put 15 in, so you got f of 15 equals 4 times 15 minus 1, which is 14. 14 times 4 is, hold on one second. 4 times 14 gives you 56. And then add the 1, so this one should be 57 for f of 15, or a sub 15, the 15th term of the sequence. Okay. Moving on to 7, again, initial value is 1. The common ratio on this one's 2. It's an arithmetic sequence, adding 2 each time. So the recursive function would say a sub n equals a sub n minus 1 plus 2. And the a sub 1, the initial value, is 1. The explicit function will say f of n equals 2 times n minus 1 plus 1. To get the a sub 15, plug in 15 into the function here. You gotta do 2 times 15 minus 1 plus 1. 2 times 14 is 28. Add 1 gives you 29. 8 has a common ratio. This is times 4 every time, and the initial value is 2. So the recursive function is going to look a little bit different from the arithmetic one. We're going to put 4 times a sub n minus 1, because it's times by 4 each time, and a sub 1 equals 2, the initial value. The explicit function is going to follow an exponential type situation, initial value times what you're multiplying by each time to the n minus 1 power. And that's the whole function. To get the a sub 15, you plug in 15 into your function. 2 times 4 to the 15 minus 1 power. So that's 4 raised to the 14th power, which is a very large number. And you have to times it by 2. You get a really, really big number that looks like this. 5, 3, 6, 8, 7, 0, 9, 1, 2. Oh, it's only a half a billion, about. Number 9 here. The common ratio is 1/3. So this one's a little bit different. You notice how it's like a pattern of divide by 3 each time. So when you're writing the common ratio, remember you take the second term and put it over the first one. And you can pick any 2 consecutive terms. When you reduce that, you get 1/3. So that's our common ratio. You can think of it as when you are dividing by a number each time, you just put that number under 1 in a fraction. Initial value is 45, so our recursive function is going to say a sub n equals 1/3 of a sub n minus 1, and a sub 1 equals 45. The explicit function follows the exponential form, so 45 times 1/3 to the n minus 1 power. And that's going to be our function. Remember, initial value, what you multiply by each time there. To get the a sub 15, you're going to plug in 15 into your function. And if you plug this in your calculator, you get a kind of a interesting looking decimal number. What I'm going to show you is what the fraction is going to look like without doing the decimal. So we got 1/3 to the 14th power. Well, 1/3 to the 14th power is the same as 1 to the 14th over 3 to the 14th. And so 1 to the 14th just gives you 1. So you're going to have 1 on top of this fraction. And then we have to do 3 to the 14th power on bottom, which is 4, 7, 8, 8, 2, 9, 6, 9. So we got 45 times 1 over that number there, which is 4,782,969. And when you do that, when you multiply that, you basically just do 45 times 1, which is 45. And now we have the fraction 45 over 4,782,969. And that can be reduced, but is basically that. And onto our onto number 10 here. This has a common difference of subtracting 7 each time. So subtract 7, initial value is 40. Recursive function is going to be follow the arithmetic form of a sub n minus 1 minus 7 there on the end, and then a sub 1 equals their initial value, 40. The explicit function is going to say f of n equals negative 7 times n minus 1 plus 40. To get the 15th term, you plug in 15. So you're basically going to do negative 7 times 14, and then you're going to add 40 after that. So 7 times 14 gives you, the negative 7 times 14 gives you negative 98, and then you're going to add 40, which is going to give you negative 58 for your 15th term. On 11, we have a pattern of multiplying by negative 2, so that's our common ratio. The initial value is negative 3, so the recursive function here is going to follow the geometric form, so it's going to be negative 2 times the previous term, a sub n minus 1. A sub 1 is negative 3, so the recursive one looks like that. The explicit one is following again the quadratic, not the quadratic, the exponential form, the geometric form. So it's going to be negative 3, initial value times what you're multiplying by to the n minus 1 power. And when you have a negative that's being multiplied each time, make sure you put in parentheses so your sign stays out the same. To get the 15th term, plug in 15 into the function. So you get negative 3 times negative 2 to the 15 minus 1 power. So that's negative 2 raised to the 14th power. And that's going to give you a positive 16384 times negative 3 times the negative 3 in there. You're going to get negative 49152. And that's our 15th term. And moving on to number 12, this has a pattern of subtracting 4 each time, and the initial value is negative 4. So our recursive is going to follow the arithmetic form, which is a sub n equals a sub n minus 1 minus 4, and then a sub 1 is negative 4. The explicit function is going to follow the arithmetic form, so negative 4 times n minus 1, and then subtract 4 on the end because that's our initial value. To get the 15th term, plug in 15 into your function and calculate. 15 minus 1 gives you 14, so you gotta do negative 4 times 14, which is negative 56, and then you subtract that 4, and that'll give you negative 60 for ending number there. And that's it.